About 50 years ago, the United States did something that many people thought was nearly impossible, and that was sending humans to the moon and returning them safely to the Earth. I'm here with NASA Administrator Jim Bridenstine. Thank you very much. I wanted to bring you in to talk a little bit about the public perception of spaceflight.
Yeah.
Now, 50 years ago, hundreds of millions of people were tuned to their TVs watching a couple of guys from NASA walk on the moon. Today, you still retain a lot of interest, a lot of public interest in what you do, but I don't think it's quite to that level. Can you talk a little bit about that, the difference in what the public thinks about human spaceflight then versus now?
I think the big difference is we have to remember what was happening back in the 1960s. We had this great power competition between the United States and the Soviet Union. And because of that, we were trying to demonstrate not just our technological prowess, but we were also trying to demonstrate that our political system was superior and our economic system was superior. And so the whole world, it wasn't just the United States, the whole world was watching to see which of these two great powers could ultimately achieve that goal first. And of course, the Soviet Union, they were first with Sputnik, the first artificial satellite put in orbit around the Earth. They beat us there. And then they beat us with Yuri Gagarin orbiting the Earth. And of course, the United States was behind. And in 1961, a couple of weeks after Alan Shepard went straight up and straight down, didn't go into orbit, but he did go into space technically, but it was straight up and straight down. A couple of weeks after that, John F. Kennedy announced before Congress, he said we need to send a man to the moon and bring him safely home to the Earth, and he put a date on it, by the end of the decade. And so that kind of spurred this great enthusiasm and momentum to see if the United States could in fact pull ahead of the Soviet Union. And of course, he made that goal sufficiently big and sufficiently long in duration that it would give us time to get ahead, to move forward ahead of the Soviet Union at the time. And of course, it was Neil Armstrong and Buzz Aldrin this month, July 20th, 1969, 50 years ago this month, they had that monumental achievement where we had humans walking on the surface of the moon. Interestingly, we did it 5 more times after that for a total of 6 moon landings, 6 landings on the surface of the moon with 12 people. And after that monumental achievement, the Soviet Union said, hey, we want to partner with the United States of America in spaceflight. And because of that, we created what was called the Apollo-Soyuz program, which of course General Tom Stafford, our proud Oklahoman, was the first astronaut to go through the hatch and shake hands with a cosmonaut on the Apollo-Soyuz spacecraft. That was in 1975, the year of my birth, as a matter of fact. And so these kind of, I think, these kind of things were at the very top of people's minds back in the 1960s, early 1970s. And I think it became somewhat normalized as we went into the Space Shuttle program, the Shuttle Mir program, another great partnership with the Soviet Union and the United States, and then eventually the International Space Station, which now has 15 nations that are partners. So I think it became normalized. But I would also say that under this administration, they want to go back to the moon, this time sustainably. In other words, we're going to stay on the moon, and not just stay on the moon, but to go on to Mars. And so they've put together a plan for us to do that. I've been putting it together on behalf of the administration, and we have increased NASA's budget significantly in the last 2 years, and of course we've made another big request for an increase in the budget to go to the moon sustainably this time, and then on to Mars.
And do you think that might capture the attention the same way the Apollo mission did? We're obviously going to be sending science unmanned missions to the moon maybe before a manned mission, but if we send people back up there, do you think people will latch on like
Absolutely.
they did before?
So the key to the whole thing is stunning achievements, and that's the history and legacy of NASA. And it's a very soft power tool for the United States of America. Back in November of last year, we landed a little robot on Mars called InSight. I say little. It's probably 2 or 3 times the size of this table. But it's doing amazing scientific experiments and discoveries on the surface of Mars. We have another rover on Mars called Curiosity. And of course, Spirit and Opportunity recently came to the end of their lives on Mars. But here's my point on InSight. When we landed InSight on Mars back in November of 2018, it was on the cover of every newspaper worldwide. Worldwide, it was on the cover. In fact, one of the interesting places that it popped up was in a newspaper in Tehran. In fact, the subtitle of the newspaper was "The Hardline Newspaper of the Islamic Revolutionary Guard Corps." Now, I will tell you, they don't print a lot of nice stuff about the United States or our international coalition that went to Mars. But in this case, it was a nice story. And of course, I saw it online and was struck by it. But again, we were on the cover of every newspaper worldwide. So there is a lot of enthusiasm for space exploration in general. And I'll tell you, it is true that human spaceflight, I think, inspires and it captures the imagination of the public. But I would also say it goes beyond human spaceflight. In the last year, we have discovered that there is liquid water 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Everywhere there's liquid water, there's life. We have discovered on Mars that the methane cycles of Mars are perfectly commensurate with the seasons of Mars. What does that mean? The probability of life just went up again. We have discovered complex organic compounds on the surface of Mars. In other words, the building blocks for life exist on the surface of Mars. They don't exist on the moon at all, 0, but they're all over Mars. So what does this tell us? This tells us that the probability of finding life on a world that's not our own continues to go up. And interestingly, because of Spirit and Opportunity, 2 rovers that lasted 10 and 15 years, well beyond their design lifetimes, we now know that Mars had a magnetosphere that protected it from the radiation of deep space. 2/3 of its northern hemisphere was covered in ocean, and it had a very thick atmosphere. In other words, in the past, Mars was habitable. It was far more like Earth than it is today. The question is, what happened to Mars? Could what happened to Mars happen to Earth? That's another interesting question. But at the end of the day, we are at the precipice, I believe, and I don't know, nobody knows, but the probability of finding life on a world that's not our own is going up. I'm not talking about bunny rabbits. I'm talking about microbial life. And if we can discover life on a world that's not Earth, I think it'll change the game. I think people will be enthused. What else is out there that we don't know about? So yes, human spaceflight, I do believe, enthuses and inspires the next generation, just like it inspired the generation of the 1960s. But I would also say that finding life on another world is equally as important to that enthusiasm.
And one of the main ways to get to Mars is to first go to the moon.
Yes.
That seems like the plan that NASA and this administration want to do. You recently submitted a $1.6 billion budget amendment after some criticism from members of the House and I think the Senate about maybe a lack or not enough detail about your plans to go to the moon. Is there any more that you're haven't shared yet about not just this first year, but the next 5 years? Is there anything that Congress should be watching out for?
Absolutely. So it is true. So the administration said, hey, we want to accelerate our plan to get to the moon. We had a plan to go to the moon in 2028. So they said, how do we accelerate? And here's the reason. Why do we want to accelerate? There's 2 risks that NASA deals with. One is technical. When we talk about technical risk, NASA has amazing capabilities to retire technical risk, and we do it all the time. So we can do that activity. Where we have not been good historically is the political risk. So when we think about the political risk, going back to the 1990s, we had the Space Exploration Initiative. and it got canceled because it took way too long. It cost way too much money. And then in the early 2000s, we had the Vision for Space Exploration, again, an effort to get back to the moon. And it resulted in the Constellation program. And again, it went over budget, took too long, and it got canceled. So this administration has said, okay, there's two risks here. There's the technical risk and the political risk. How do we retire the political risk? Well, you accelerate. The challenge is, as time goes on, administrations change, budgets change, priorities change, distractions happen, world events happen. So if we want to retire the political risk, let's accelerate. So we said, okay, let's take what we were planning to do for 2028, and let's take those elements, 25, 26, 27, and 28, those years, and move them forward. What does that mean in the total architecture? Already under development, we've had the Space Launch System, the biggest rocket ever built, taller than the Statue of Liberty, more powerful than the Saturn rockets that took Neil Armstrong and Buzz Aldrin to the moon. We also have the Orion crew capsule, which is the crew capsule that will take our astronauts to the moon. And we have the European Service Module, which is, think of it as the life support system and the propulsion capability for that Orion once it's at the moon. So those pieces of the architecture get us into orbit around the moon, the vicinity of the moon. Now, we need more, what we call at NASA, delta V. We need more energy, because with all of that energy, we can get to low lunar orbit, but we can't get out of low lunar orbit. So where do we get, because we just need more energy, more fuel. Where do we get that fuel? Where do we get that energy? Well, that's where we take those elements from 2025, 26, 27, and 28, and we move them forward. We need to build what we call the gateway. Think of a space station in orbit around the moon. You go back to the Apollo program. In the Apollo program, we had a command module in orbit around the moon while our astronauts were walking on the surface of the moon, and then they launched back to that command module. The Gateway, this small space station that we're building in orbit around the moon, is a reusable command module. It doesn't get thrown away like during the Apollo program. We can use it for 15 years. It's going to be permanently in orbit around the moon for 15 years. Now that Gateway, think of it as a small space station, is where our astronauts can transfer from, remember, the SLS and the European Service Module and the Orion crew capsule. That stack goes to the Gateway, which is in orbit around the moon. And at that Gateway, that small space station, there will be aggregated a lander. So then they get in the lander, they can go to the surface of the moon, and then back to the Gateway. The reason the Gateway is important, again, it's reusable. It will be there for 15 years. The landers, we want the landers to be reusable. They can go back and forth to the surface of the Gateway over and over and over again, driving down the cost of access to the moon and increasing the access to the moon. These are the capabilities that during the Apollo program, had we instituted, we would have been on the moon this entire time. The challenge is it was so expensive because we didn't build sustainability into the program. This president has said in Space Policy Directive 1, go to the moon sustainably. He also said go with commercial partners. That didn't exist in the previous efforts to return to the moon. Now we have commercial partners. Companies like Jeff Bezos has a company called Blue Origin, and Elon Musk has SpaceX, and Sir Richard Branson has Virgin Galactic. Plus we've got traditional contractors like Boeing and Lockheed and Northrop Grumman that are now competing in a very commercial kind of way to increase more access, drive down costs, and increase access to the surface of the moon. So we think about the Gateway, a space station in orbit around the moon. We think about landers that can go back and forth to the surface of the moon from Gateway. The entire architecture, after we get to the moon, the Orion crew capsule, we want that to be reusable as well. Elements of that will be reusable. Again, going back to Apollo, we are trying to avoid the trap of Apollo, which is the entire system gets thrown away on every mission. Now we want to build reusability into the program and eventually even have reusable launch capability. We've already demonstrated reusable launch going to the International Space Station, commercial resupply, commercial crew. These capabilities to low Earth orbit have demonstrated that we can bring rockets home after we launch them. And of course, NASA set the parameters by which this has now been successful by private industry. Now that private industry can take it to the next step, which of course is to the moon. So The goal is NASA needs to be a customer, one customer of many customers in this architecture, and we need numerous providers that are competing on cost and innovation, driving down cost, increasing access. So the value of the gateway is it builds reusability into the system, driving down costs for the long term. It also has solar electric propulsion, which means we don't just have to land at that equatorial region of the moon the way we did back in the 1960s. We can have access to the entirety of the moon. Why does that matter? Because in 2009, we discovered hundreds of millions of tons of water ice at the south pole of the moon. What does that mean? If we want to stay on the moon for long periods of time, water ice is life support. It's air to breathe, it's water to drink, it's also power, it's propulsion. Hydrogen and oxygen, if you crack water into hydrogen and oxygen, put it into cryogenic liquid form, that is the same propulsion that powered the space shuttles. It's the same propulsion that will power the SLS rocket. It's the same propulsion on the Saturn rockets that took Neil Armstrong and Buzz Aldrin to the moon. And it's available on the south pole of the moon in hundreds of millions of tons. So all of this conspires to say we can go to the moon sustainably with international partners, with commercial partners. We can drive down costs, we can increase access, and we can use the moon as a proving ground for our mission to Mars, which the president has been very clear, we're going to Mars. So why does it matter that we need the moon to get to Mars? The challenge with Earth and Mars is that we are only on the same side of the sun once every 26 months. So when we go to Mars, we've got to be prepared to stay. Now there are some orbital physicists that will tell you that we could do a short duration stay on Mars for maybe 30 to 60 days. It's very difficult. We need a lot of propulsion capability to make that happen. Another option would be just to stay on Mars for a period of 2 years until Mars is again aligned with the Earth. Either way, you're going to have to stay on Mars for a period of months, if not years. The moon is the proving ground. How do we learn how to live and work on another world so that we can eventually take those capabilities onto Mars? So as we're building this architecture at the moon, we're not only doing it with an eye for sustainability, we're doing it with an eye for what technologies feed forward to Mars, so that ultimately when we get the moon complete, when we're ready, we can take everything we've learned and we can take it onto Mars. Now Mars is different than the moon. Mars has an atmosphere. So the way we do entry, descent, and landing on Mars is going to be a very complex system that we don't have to do at the moon. But everything else, when we talk about the gateway, when we talk about, in other words, that habitat in orbit around the moon, we can apply that to Mars. When we talk about the launch, the ascent vehicle from Mars to the gateway, all of those elements are replicable. And so that drives down cost, increases access. So one other thing I think that's important, the architecture that we're building at the moon, and of course will eventually apply to Mars, is open. When I say it's open, what that means is the way we do data, the way we do communications, the way we do docking and life support and avionics, all of those systems are going to be open and available on the internet. So any small country that wants to partner with the gateway to have their own access to the surface of the moon, they can partner with us. In fact, any company, if a private company wants to build their own lander and partner with the United States to have access to the surface of the moon, they can partner with us. Because we believe there will be markets that form that are not NASA. The history of NASA is that we were the only game in town, and either NASA went or nobody went. So the future is very different. There will be other countries that can partner with us in an open architecture, and they can have their own access to the moon. And there will be other private companies that want their own access to the moon. And we want to partner with them in that effort. Why? Because again, then they can share costs, drive down costs, increase access, and some of their markets will include, it could be a market for the water ice for fuel. It could be a market for platinum group metals, which we don't know, but could exist in mass quantities on the moon. It could be a market for tourism. All of these things that enable us to do more, we want to take advantage of.
Right. It sounds like NASA's got a really exciting next few years, and hopefully maybe with someone landing on the moon. That's about it. If you would care to follow the Oklahoman and our Apollo 11 coverage. We'd appreciate it. Thank you again, Administrator Bridenstine, for joining us all the way from Washington, D.C., and hope you have a good week.
Thank you. You too. Appreciate it very much.